Next on the program, again, I'm very honored and delighted to introduce Dr. Dan Katz from the National Science Foundation. Dan is, I would say, a colleague of a while. We cross our roads at multiple conferences series. For example, eScience this year is upcoming. If you're interested in that conference, it's going to be in Chicago, just to do a little bit of spread word. And the supercomputing conference, of course. Dan has a long time distinguished career. Before went to NSF, he was with the Computation Institute at the University of Chicago. Argonne National Lab joined the institute. He's an expert of parallel computing, distributed systems, numerical methods, parallel algorithms, and so forth. Dan is one of the program officers in the Office of Cyber Infrastructure responsible for our NSF project. Without further ado, thank you very much, Dan.
Okay, thank you. I wanted to say, actually, to begin with, it's very interesting to me to hear about cyber infrastructure from a university administration. I think it's actually very encouraging. What we're trying to do at OCI, the Office of Cyber Infrastructure at NSF, really is only possible in some sense if universities get behind it and equally push the area forward. We certainly think that this is an important area, but again, universities really have to do the majority of the work, and universities are going to have to change to some extent to really make things move forward. So with that, I want to talk about my view of where we are in software, and this is really based on the software programs that we have at OCI, which cross a bunch of different areas at NSF. So just to start off with, it's always worth, I think, mentioning what cyber infrastructure is. This definition from Craig Stewart is probably my favorite. Computing systems, data storage systems, instruments, data repositories, visualization environments, and people linked together by software and high-performance networks to improve research productivity and enable breakthroughs not otherwise possible. So the key piece of this is that the software is part of the infrastructure. It's developed by individuals and groups. It's often international, and it's developed for a purpose and has to be used by a community. And if these things at the bottom aren't there, all right, then you're building software, but it's not actually useful, and then we're not really very interested. So we'd like to think about kind of these different elements. Who's developing it? What are the partnerships? Who's using it? What's the community? Software really is part of infrastructure here. So we think of a cyber infrastructure having a number of components in it, and one of those components is various software packages. Software is becoming an integral enabler across really all science and engineering disciplines, in computation and experiment theory, and again, it's a central piece of the overall cyber infrastructure. Software is fitting in between science on the top and the hardware infrastructure on the bottom. Software is. It's enabling education as well, right? And education enables further software to be developed. So it's not just research, it needs to be tied in quite closely with human development. As applications are becoming more complex, multi-scale, multimodal simulations, for example, new data analytics, there's software challenges associated with that. As the as the environment and the applications become more complicated, right? The environments and applications become heterogeneous and distributed and massively parallel, then there's new software challenges associated with that. There's, of course, the existing challenges associated with software engineering for robustness and usability and reliability and verification and validation and other things. And one of the things I think we would say is perhaps equally important, if not more important, are some of the policy issues in the research environment. How to motivate people to write software and to share software. How to get people credit for writing software that's used by other people. How to deal with licensing. How to deal with software that has to cross multiple disciplines and international boundaries. And I guess the last piece of this slide I wanted to mention is that if we think of scientific discovery and technical innovation and software in the middle, we can think of innovation driving software that drives discovery, or we can think of discovery as having requirements for software that drive innovation on the other side. So software really, in our view, has a central role in both science and technology. So at NSF, in the software programs, we think of the central thing that we're really trying to do is to create and maintain a software ecosystem that provides new capabilities to advance and accelerate scientific inquiry. In order to do that, we need to bring in foundational research. All right, so there's computer science research, there's research in different domains, that people are trying things, and as those things work, we need to make sure that they move into the ecosystem and they become available to more people. The goal of this ecosystem, again, is to really enable the science and engineering research and education to be done. All right, so that's the output in some sense. And then there's other pieces here as well. All right, so one of them is that we have to transform really what's going on in practice by new policies. Again, there are questions about academic culture, open dissemination and use, reproducibility and trust, curation, sustainability, governance, citation, stewardship, attribution of software authorship. All right, there's a number of issues that all have to go in to the software that's in the ecosystem. And then finally, the ecosystem itself, as I mentioned before, has to be involved in developing the next generation workforce of scientists and engineers. Right, so the new scientists and engineers have to have the skills to use the software. They have to have the skills to develop the software, but the software itself then also can help in the education process. So in the Office of Cyber Infrastructure in particular, when we think about software, we think of our role in a number of ways, including that we should be contributing to the development and the deployment of a comprehensive, integrated, sustainable, and secure cyber infrastructure at both the national and international scales. We want to have the cyber infrastructure have an impact that goes across multiple research disciplines. Right, so just as an example, if something's happening in one particular research discipline, let's say chemistry, then it probably doesn't fit into OCI, it probably fits into chemistry. But if we're doing things that are in multiple disciplines, then that's where OCI gets involved. As I said before, we want to promote the transition from basic research into practice. And we want to think of software as being part of the cyber infrastructure. So where we're investing in large instruments, large telescopes, large facilities, we want to make sure that the software that enables those is also available and is linked in. So internally within NSF, and this is helpful perhaps for people that are writing proposals, the way that this actually works is that we have a cross-NSF software working group that has members from all the different science directorates. And together we talk about solicitations that are coming out, that we're going to write, determine which disciplines are going to participate in each one, which is based on the discipline's interests and budget and a number of other things. And then we try to record that in the solicitation so people that are going to be writing proposals can understand really what potentially is going to be successful and what might not be successful in a particular solicitation. Once the proposals come in, the software working group discusses all of the proposals, and we run a review process that tries to take into account expertise from all the different areas. And then once we've gone through that review process, we again come back together and try to figure out which of those proposals are going to be funded in a collaborative way. So when you look at a solicitation, it may have one person's name at the top, it may have a lot of people's name at the top, but in general, there's a process going on behind the scenes which really has a lot of discussion happening. And our goal, again, is to really try to fund the things that are going to lead to the best science in the long run, no matter where they're coming from. So specifically in the SI2 program, Software Infrastructure for Sustained Innovation, which is the thing that I run and the thing that's actually funded the CyberGIS project, we start off with software elements. So we have small projects, maybe one PI, maybe two PIs, a student, that are building up little pieces, and we may have groups of these. We have then what we would call software integrations or software frameworks. So these are things that hopefully look at a number of software elements and put them together and think of starting to build larger projects out of those. And then finally, if we think of a number of these different projects, a number of different elements, a number of different integrations or frameworks, we then think of institutes on top of that. So we're just starting the process of having software institutes. We're in the process of making some conceptualization awards to have people start thinking about these and write full proposals in about a year or so. But the idea is that these software institutes are going to link together a number of these, a number of the elements, a number of the integrations, a number of the frameworks in different areas. In the background of all of this activity is something that we're calling software reuse. Software reuse has been something that's been internal inside of NSF at this point. We've looked at projects, and if we see a project coming out somewhere that has software being developed and we think if we gave a little bit of extra money to this team, they could make the software public and other people would be interested, then we've done those things kind of behind the scenes. And so some people may have gotten awards that have been, that had some extra direction saying, in addition to what you were saying you were going to do, can you put a little bit of extra effort into trying to make this reusable or trying to reuse something that somebody else has? All right, so we've been doing that internally. It's likely we'll expose that externally in the future, and you may see something about opportunities for software reuse and to get some extra funds and awards for that. And if you're interested in these things, there's a couple of past solicitations, 11.539 and 11.589. Are past solicitations. The first one dealt with the elements and the integrations. The second one dealt with the institutes. There's a current solicitation out called 576 that is looking at this middle category, software integrations, but specifically in the context of grand challenges in chemical sciences. So it's very tightly focused. It also has to be US-UK collaborations. So it's extremely tightly focused. But there will be more broad solicitations coming out in the future looking at these areas again. So keep an eye out for those things. Finally, it's worth just mentioning that if you look at the grant and proposal guide, it describes opportunities for supplements and for eager proposals, which are kind of new ideas that can be tried over a year. I think most program officers, including me, are interested in hearing ideas of these things. We think of the solicitations as being the kind of the framework where we express our interest in what we think we'd like to see in research, and these other opportunities like supplements and eagers as the way that the community says, here's what I'd really like to do. So if you have ideas that seem to fit into this software area or other things, again, most program officers are certainly interested in hearing what your ideas are and trying to see if there's some way that we can make them happen. So finally, I just want to close with some of the open software questions that I think we as a program are thinking about. So the first one is that if we're thinking of software as infrastructure, there's some interesting challenges to that. If we think of software in business, like Microsoft with a product, for example, if they get more customers, that means they have more money and they can support their software better. Right? If you're doing open source software and you get more customers, that means more work for you. Right? And there's not really a reward. So we're trying to figure out really how do we deal with things like that. The last 20% of the work to make something really usable, to move it from a paper into a product, may take 80% of the effort. Right? So how do we really fund things like that, and how do we decide which things are worth doubling the funding for in some sense to make them reusable? What can NSF do to make these things easier in general? How do we measure the impact of software? Right, so if the CyberGIS project, as an example, is building software, how do we measure the impact of that software on the science that happens? What about all the software that's going into that project that's coming from other things? Right, so how do we go back and measure the impact of that and in some way reward the people that did that original work, even though they had no idea that it was going to be used in this project? What fraction of funds in terms of our office should we be spending in terms of supporting infrastructure that's existing rather than developing new infrastructure? Right? So we can't continually support more and more things, because if we do that, we'll stop supporting new things. Right? So somewhere there has to be a balance, and at this point I don't think we have the best idea where that is. How do we decide to stop supporting something? Right? So when does a software package that we've been supporting for a while, when do we make the decision that we're no longer going to support that? Perhaps there's something else that's come out that the community is moving to. Perhaps the developers have decided they're not going to support that any longer. So there's no person that's really able to do that. So there's questions there as well. And then finally, how do we encourage software reuse and discourage duplication? Right, so my work in some sense has been in workflows. And there was a study at one point that I think there were something like 130 different workflow packages supported by NSF at one point. Right, so that's probably too many. But one is probably too few. And kind of where do we draw the line? And again, how do we encourage people that are writing new proposals not to develop another package, unless there's a really good reason, but to try to use one of the packages that exist? So with that, I'll stop, and I don't know if there's time for any questions.
Sure.
Okay, so if anybody has questions, I'd be happy to try to answer them as well.
Very simple question. Coming from an enterprise environment where we had, thousands of software and applications, how do you keep an inventory of those things? Is there something that we can search when we're thinking about doing development?
Yeah, so that's a really good question as well, and I don't think that we have an answer at this point, but it certainly is something that we're thinking about and we're starting to try to build up. So the awards that we've made in this program in particular, we've been asking people, please send us a little bit of information about the software that you developed and that you believe is reusable. And we're trying to put that together into a list, but unfortunately, that's kind of part of the answer because there's all sorts of other things, right? There's the software that DOE supports, there's the software like Linux that's really, right, that isn't federally funded. There's software from other countries. I don't think we have a good answer for that overall, but again, I hope in the next 6 months or so, we'll be able to say, here's the software that NSF is supporting for some time and try to give people confidence that that software is going to be available at least for that period of time. And once you do that, then there's still a question because, right, as an applications person or as a developer, you have to decide, what am I going to use from somebody else? And in that process, you have to say, all right, what faith do I have that this is going to be around in 2 years or in 5 years? Right, and NSF isn't going to be able to say something's going to be around at that point. So it's part of the answer, but it's not the full answer.
Thank you.
Any other questions? We might have time for one more question. Yep.
So in regards to workflow, the CyberGIS project is, I would say, I'm going to lay the dirty laundry out there, is struggling a little bit, perhaps because of the 130 plus or whatever. So in terms of your work, for example, what would you say is, take three of those 130 in this area that we're in, what are 3 different workflow engines that might be useful to really look at in terms of where we could take this project and leveraging some other work that has been done?
Yeah, unfortunately, that's an answer that I don't want to give.
Fair enough. I'll let you off the hook at this point.
Yeah, I mean, so I don't really want to say that there's something that's better than something else. There's a number of things that we've been funding. There are a number of things that we haven't been funding. I guess I can talk to you maybe offline and tell you kind of, at least from my view as a technologist rather than as a program officer, what some of the families are and maybe some of the representatives of the different families.
How about then, sorry, as a follow-on, one good or that you think the best article that's been written out there about evaluation of workflows? Is there such a piece? I've come across a couple, but I'm not going to say what they are, because independently I'd like to...
No, I actually don't. I would say that I don't think that there has been really the definitive article written at this point. I think that's something that would be a very good contribution from somebody, but and I've talked about this kind of, again, not as a program officer, but as a researcher. I've talked about some of the aspects, and unfortunately trying to do that means that you have to figure out what the criteria are, and then have maybe some samples that you're trying to run through different systems and figure out different experiences, and it's not a simple thing to do, and I don't think that anybody's done it, to my knowledge, sufficiently well at this point.
It's sort of like a dissertation topic.
And it certainly could be, except if it was a dissertation topic, it would be one without original research that probably wouldn't be very successful. It's something, but probably not a dissertation topic.
Well, let's thank Dr. Dan Katz once again for